Welcome to the sixth lecture on trigonometry. The topic is trigonometric identities for double angles. I am your lecturer, Professor E.O. Efa. Trigonometric identity for double angles. 1. Prove that sin 2a is equal to 2 sin a cos a. Proof. We recall that sin a plus b is equal to sin a cos b plus cos a sin b. Let us put b equals to a, then sin a plus a is equal to sin a cos a plus cos a sin a. That is, sin 2a is equal to 2 sin a cos a. Since these two terms are like terms, we can add them. 2. Prove that cos 2a is equal to 1 minus 2 sin squared a. Proof. We recall that cos a plus b is equal to cos a cos b minus sin a sin b. Let us put b equals to a, then cos a plus a is equal to cos a cos a minus sin a sin a. That is, cos 2a is equal to cos a is cos squared a minus sin a is sin squared a. By our fundamental identity, cos squared a is 1 minus sin squared a. So therefore, cos 2a is equal to 1 minus sin squared a minus sin squared a. Minus sin squared a minus sin squared a is minus 2 sin squared a. Therefore, cos 2a is equal to 1 minus 2 sin squared a. 3. Prove that cos 2a is equal to 2 cos squared a minus 1. Proof. We recall that cos 2a is equal to cos squared a minus sin squared a from number 2. Again, by fundamental identity, sin squared a is equal to 1 minus cos squared a. So therefore, cos 2a is equal to cos squared a minus, in bracket, 1 minus cos squared a. When you open this bracket, we will obtain minus 1 plus cos squared a. Cos squared a plus cos squared a is 2 cos squared a. So therefore, cos 2a is equal to 2 cos squared a minus 1. Number 4. Prove that tan 2a is equal to 2 tan a all over 1 minus tan squared a. Proof. We recall that tan a plus b is equal to tan a plus tan b all over 1 minus tan a tan b. Let us put b equals to a, then tan a plus a is equal to tan a plus tan a all over 1 minus tan a tan a. That is, tan 2a is equal to tan a plus tan a is 2 tan a. Tan a is tan squared a. So therefore, tan 2a is equal to 2 tan a all over 1 minus tan squared a. Example 1. Without using tables or calculator, find the values of a sin 22 and a half, b cos 22 and a half, and C, tan 22 and a half. Solution. Using the identity cos 2a equal to 1 minus 2 sine squared a, let us put a equals to 22 and a half. Then we have cos 45 is equal to 1 minus 2 sine squared 22 and a half. But cos 45 is 1 all over root 2. So this is equal to 1 minus 2 sine squared 22 and a half. That is 2 sine squared 22 and a half is equal to 1 minus 1 all over root 2. Please note 1 minus 1 over root 2 is root 2 minus 1 over root 2. Dividing both sides by 2, we obtain sine squared 22 and a half is equal to root 2 minus 1 all over 2 root 2. Now let us multiply and divide this by root 2. That's, we are rationalizing the denominator, and that will give us 2 minus root 2 all over 4. Now taking square root of both sides, we have sine 22 and a half is equal to square root of 2 minus root 2 all over square root of 4, which is 2, and that will give us 1 all over 2 root 2 minus root 2. B. Using this identity, cos 2a equal to 2 cos squared a minus 1. Let us put a equals to 22 and a half. Then the identity will become cos 45 is equal to 2 cos squared 22 and a half minus 1. Cos 45 is 1 over root 2. So that is 1 over root 2 is equal to 2 cos squared 22 and a half minus 1. That is 2 cos squared 22 and a half is equal to 1 plus 1 all over root 2. 1 plus 1 over root 2 is root 2 plus 1 over root 2. Dividing both sides by 2, we obtain cos squared 22 and a half is equal to root 2 plus 1 all over 2 root 2. If we rationalize the denominator by multiplying and dividing by root 2 and taking square root of both sides, we obtain cos 22 and a half is equal to half root 2 plus root 2. C. Tan 22 and a half is equal to sine 22 and a half all over cos 22 and a half. This is equal to half root 2 minus root 2 divided by half root 2 plus root 2. Half will cancel half, and this will give us root 2 minus root 2 all over root 2 plus root 2. If we multiply and divide by the square root of 2 minus root 2 all over the square root of 2 minus root 2, this will give us 2 minus root 2 all over root 2. And this is equal to 2 minus root 2 minus 2 all over 2. If we divide through by 2, that will then give us tan 22 and a half equal to the square root of 2 minus 1. Example 2. Prove that sin 2a is equal to 2 tan a all over 1 plus tan squared a. Proof. We recall that sin 2a is equal to 2 sin a cos a. Let us write this as 2 sin a cos a all over 1. But by fundamental identity, this is equal to 2 sine A cos A all over cos squared A plus sine squared A. Now let us divide the numerator and the denominator through by cos squared A to obtain sine 2A equal to 2 sine A cos A all over cos squared A divided by cos squared A over cos squared A plus sine squared A over cos squared A. In the numerator, cos A will cancel cos squared A to give us 2 sine A over cos A. Cos squared A will cancel cos squared A here to give us 1. And this will give us 2 sine A over cos A all over 1 plus sine squared A all over cos squared A. But sine A over cos A is tan A. And sine squared A over cos squared A is tan squared A. So therefore, sine 2A is equal to 2 tan A all over 1 plus tan squared A. Example 3. Prove that cos 2A is equal to 1 minus tan squared A all over 1 plus tan squared A. Proof. We recall that cos 2A is equal to cos squared A minus sine squared A. Let us write this as cos squared A minus sine squared A all over 1. Then by fundamental identity, this is equal to cos squared A minus sine squared A all over cos squared A plus sine squared A. Let us divide the numerator and the denominator through by cos squared A. This will give us cos squared A over cos squared A minus sine squared A over cos squared A all over cos squared A over cos squared A plus sine squared A over cos squared A. Cos squared A will cancel here to give us 1, and it will cancel here to give us 1. Sine squared A over cos squared A is tan squared A. So therefore, cos 2A is equal to 1 minus tan squared A all over 1 plus tan squared A. Example 4. Prove that tan theta plus tan 90 minus theta is equal to 2 cosec 2 theta. Proof. Please recall that tan 90 minus theta is equal to cot theta. So we have tan theta plus tan 90 minus theta is equal to tan theta plus cot theta. This is equal to tan theta plus cot theta is 1 all over tan theta. And this is tan square theta plus 1 all over tan theta. That's finding the LCM, which is tan theta. But tan square theta plus 1 is sec square theta. So this will give us sec square theta over tan theta. That is equal to 1 all over cos square theta, since sec square theta is 1 all over cos square theta. Then times 1 all over tan theta is cot theta, and cot theta is cos theta over sin theta. Cos theta will cancel cos square theta to give us 1 all over cos theta sin theta. Let us multiply and divide by 2 to obtain 2 all over 2 cos theta sin theta. But 2 cos theta sin theta is sin 2 theta. So this will give us 2 all over sin 2 theta. That is 2 times 1 all over sin 2 theta. And that will give us 2 cosec 2 theta. Example 5. Prove that Cot 90 plus theta plus tan 90 minus theta is equal to 2 cot 2 theta. Proof. Cot 90 plus theta plus tan 90 minus theta is equal to, we had earlier shown that cot 90 plus theta is equal to minus tan theta, and also tan 90 minus theta is equal to cot theta. So this is equal to cot theta, which is cos theta over sin theta, minus tan theta, which is sin theta all over cos theta. The LCM here is sin theta cos theta. Sin theta cos theta divided by sin theta is cos theta, times cos theta will give us cos square theta, minus sin theta cos theta divided by cos theta is sin theta. Sin theta times sin theta is sin square theta. But cos square theta minus sin square theta is cos 2 theta. So this is equal to cos 2 theta all over sin theta cos theta. If we multiply and divide by 2, we obtain 2 cos 2 theta all over 2 sin theta cos theta. But in the denominator, 2 sin theta cos theta is sin 2 theta. So this therefore is equal to 2 times cos 2 theta all over sin 2 theta. But cos 2 theta all over sin 2 theta is cot 2 theta. So therefore, the expression is equal to 2 cot 2 theta. We have come to the end of lecture 6. Thank you for watching, and keep on watching.